Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host as usual is Tobias Macy, and today I'm interviewing Romain Dorgueil about Bonobo, a data processing toolkit for modern Python. So, Romain, could you please introduce yourself?
Hi, Tobias. So first, thank you very much for having me on the podcast. So I'm Romain Dorgueil. I'm the creator and main developer of Bonobo ETL, a Python library to extract, transform, and load data. Sometimes I define myself as a Python hacker, but I mostly tend to see technology as a mean more than an end, and I like building solutions and seeing how it can change how humans use things and do things more than the actual technology behind it.
And do you remember how you first got introduced to Python?
Yeah, so that's quite funny because I grew up in a let's say early Linux powered house. We had Linux boxes at home around like 95, something like this, mostly thanks to my father. The first distribution we used were Red Hat distributions, and at some point they used this thing called Anaconda, which was the installation system, not the Anaconda we know in the Python distribution world. So some people told me, yeah, the Anaconda thing is made with Python. I didn't know about Python then, and they told me it in about very nice terms. So a few years later, I had to start doing some system engineering work in a team of software engineers. I had to help them raise the quality of what they were delivering, what the deliverables. And I started using quite naturally Python for that, and that was pretty much my first encounter with that. So it was probably bad code I was writing by then, but that's the first real professional encounter I had with the language. And after that, I started building companies at some point. And while we had a bunch of PHP software, the obvious choice I had for handling data processing was Python. Yeah, and it's at this time I started to work on ETL libraries, and that would at some point be rewritten in Python 3.5 as Bonobo.
And that leads us nicely into a brief discussion about what Bonobo is and what motivated you for creating it. And it sounds like it was a sort of generational evolution to the point of having Bonobo, where there might have been some previous incarnations.
Yes, mostly I hit my head against the wall a lot of time about transforming data. Yeah, it was kind of iterative process. So just to tell what Bonobo is, so it's an extract, transform, load, maybe a framework. Maybe not everybody is familiar with this term, so I try to explain it in simple terms. For me, ETL is just a fancy term to say a system that moves and transforms a bunch of data from one place to another. And I say it's an ETL framework because the goal here is not to reinvent the wheel about how we will organize things, how we will structure the files and the data every time. I put in place some guidelines to guide teams of engineers about that. And it helps also running the thing efficiently so that the teams can just be about writing jobs, writing data transformation jobs instead of reinventing all that. And if we jump back in time, like you said, in like 2011, I think, when I started to get interested in building companies, I had to find a way to integrate a lot of catalog data at the time that came from a lot of different systems into our databases and data stores. I mean, we are working with computers, but out there it's pretty artisanal. So each of our partners had their own ways to store the catalogs, the stock, the store informations. And even the partner that would use the same vendor softwares has a difference between them. So we had to deal with XML, JSON, CSV, probably other format I don't remember. Some would provide the pictures associated with the catalog items on FTP servers. Sometimes they would push to our own FTP server. Some would make them available on HTTP. For some, we even had to scrap their e-commerce website because they didn't have the pictures and they didn't know how to get them. And there were some structural properties differing from one system to another, especially regarding the identifier of the product. And then we would eventually have to match their taxonomies with our internal taxonomy. So yeah, there was a bunch of things to do, a lot of things. And as you add different partners, it becomes harder and harder to do it properly each time. So at the time we started using graphical ETL because ETL is not new. It's like the 40 last year at ETL software, and we used something called Penthouse data integration, which is Java IDE for ETL, and it's all graphical. So you just point and click and draw boxes and draw the data path between the boxes. So it did the job at first, but it required a lot of copy pasting between jobs because we had partner 1, then partner 2, then partner 3, and 90% of the job was the same from partner to partner, but the 10% left was the real problem here because once you start copy pasting thing, you want to find to fix a bug sometime, and it's just not possible because you have to fix it in 20 different files. So it's the moment I wrote my first ETL library. It was Python 2.7. It was open source also. It's still available, but it's not really a good code quality. Mostly we had to be pragmatic. We were building a business, so we didn't round the corners. We just tried to get the job done. And we used it for quite some time, like a few years. At the end, what took weeks to integrate at first was just a few hours to integrate a new partner at the end. So it was pretty great for us. And it was great because we could not humanly ask for high setup fee to our clients. We needed to be easy and quite cheap to integrate. Yeah, it did the job, and probably we were integrating something around 20 million catalog items a day with this system, only using one computer. It was not distributed across more than one, but it was sufficient for on it. Then probably last year or a bit before, I started to have similar work to do again, not at all for catalog items, but for different things we use here, mostly contacts and personal data, personal informations. This is the point where I decided to rewrite it from scratch, still as open source, using the same concept that proved efficient in my previous job, but much more accessible and much more mass market than it was before. It's always good to start from a white, from a clean sheet, because you can take drastic decisions without having to worry about anything. So it was pretty easy to drop Python 2 support. I could wipe all the code that was either flaky or not necessary. I could fix some real deeply tied structural defects that lived in the old code base. That was basically when Bonobo was born, and at the point I was not really certain I could go further than just something very confidential and not really used. But then I got this featuring on the homepage of Hacker News that drew a lot of traffic to the website, and a lot of comments, a lot of user giving their opinion, either because they seen the software or just because they read the message and said, oh yeah, that sounds great, or that sounds that you don't have a lot of information about monkeys or anything. That just throwed whatever was in her head, in their head. And that really gave me a lot of energy toward making it a real thing, really serious work, really a serious project. It's basically evolved a lot since then, but that's really thanks to all the interaction and all the feedback I got at this point. And since then, I met a lot of different companies that are reinventing the wheel again and again in the ETL field, each one for themselves, probably hidden somewhere, not really open source or partly open source, not really documented. This talking with them just confirmed to me that the problem exists, is real, and that people really need some piece of software to do this. And so that there is a real need, and that's indeed a big part of the motivation and all the energy I have to put in this project.
And what led you to choose the name Bonobo for the project? Is there any particular backstory behind that?
There's a bit of a story. The previous one was called rdc.etl, and if it taught me something, is that cryptic names using acronyms nobody understands is not really good for a project. So I started diving into a name that was symbolic, that had a meaning. And I really liked the idea of like an army of tiny monkeys just working your data one packet at a time, then passing to the next monkey in an assembly, the kind of assembly line of data. From all the names available on PyPI, Bonobo was there. At the time, I didn't really know that bonobos are not monkeys, but apes. For my defense, in the French language, there is no difference. That we have only one word for both. So Hacker News told me that I was just not informed at all, and that I had no attention to details because it's not a monkey. But I guess that's not really important for. But yeah, that's the story behind it. Now it's just Bonobo, so I'm pretty happy with the name.
Some of the other tools in the Python space for doing ETL jobs that people might be familiar with are things such as Luigi or Airflow. So I'm wondering if you can just take some time to do a bit of compare and contrast between the use cases that Bonobo is targeting and what people are using Luigi and Airflow for.
Yes, definitely. In fact, that's a very good question because I get that asked quite often. And I think it's a very different kind of projects, but people are easily confused about comparing it because both are using the DAG word to describe how they store data structures. DAG is directed acyclic graphs. So it's a kind of basic data structure for computing, but we both use it for different reasons. Also, Luigi and Airflow are used for ETL, so it's easy to say, yeah, what's the difference? As far as I understand it, Airflow and Luigi are more like GNU-make with superpowers. It's tools that allows you to schedule tasks and to describe the dependencies between tasks. So, for example, if you have C that depends on B that depends on A, you create a graph that says, okay, all those tasks have those kind of dependencies, and if you want to build C, then the system knows that it should build B. It should build B, which needs A to be built first. And so it's really, okay, wait for all my dependencies to be built before I start this thing, and then aggregate all the monitoring data, like how much time did it take, were there errors, etc. on this thing. Bonobo, on the other hand, is more like a data flow or data streaming solution. It uses graphs also to describe what you want to do, but it uses them to say, okay, whenever something goes out of A, then it should be inserted in, like it should be put in B, and whatever goes out of B should go in C. But it won't wait. I mean, the A and B and C in Bonobo are really tied together and work as a whole. It's not when A is finished, do B. It's streaming between A and B. I don't know if that's a clear explanation of the difference.
No, that definitely makes sense because particularly given that Luigi and Airflow are also more focused on large distributed task graphs that are going to be spanning multiple systems where you're pulling things out of a set of flat files, doing some manipulations on them, putting them into maybe a Hadoop cluster, and then triggering a MapReduce job, waiting for that to complete, and then taking the output of that to put it into a database somewhere, for instance. Whereas from what I was able to gather from Bonobo, the use case is more focused on being able to do in-process ETL jobs where you're taking the output of a SQL query, doing some manipulation on that, and then maybe uploading that to S3 as a set of flat files or something along those lines.
Yeah, definitely. And as a result, I'm really looking forward to having integration between Bonobo and Airflow, especially since it joined the Apache incubator, because it would really make sense to have, for some tasks, Bonobo just handle the thing, then have Airflow just grab the errors that may go out of a task, and whenever a task is done, do some other thing that may or may not involve Bonobo. I think both systems could work together quite well.
And some of the other tools that are more focused on doing data streaming processing are things like Apache Spark or Apache Beam, which are implemented on top of the JVM but are often interfaced from Python programs. So I'm wondering if you can do a bit of compare and contrast on the use cases for those solutions versus Bonobo.
Yes, so it's the value proposition is much closer, so it's tougher to answer this one. But mostly Bonobo focus on being like a Swiss Army knife for data, while systems like Beam or Spark mostly tools designed by huge structures to handle big data first. So there are different scales of data, and I think if you're a GAFA and you have hundreds of terabytes of data, Bonobo is definitely not the right tool for that, and there is tools like Beam and Spark that are really good at doing that. But being big data first and GAFA first focused comes with a price, and the options you have to start with Beam or Spark today are of two different kinds. You can either tie yourself to a cloud vendor. You all know them, but you can choose Amazon, you can choose Google, and just have them run it for you, and then it will be not quite easy. It can be very hard, or it can be just hard to just say, okay, I'm leaving Google for Amazon, or I'm leaving Amazon for Microsoft or anything. And the other kind of options you have is, if you want to run it locally and run it on your own infrastructure, is to install and maintain a costly infrastructure. If you just want to just work with some web service, work with some SQL, etc., you probably don't want to pay the price of a costly infrastructure just because you want to have a small tool that you can just run locally and try things and at some point deploy. So I'd say it's really made for different scales of data. I want at some point to explore a bit the bottom of the big data world with Bonobo, but mostly it's not the same goal and the same scale at all. Also, you told that Beam and Spark are based on the JVM, and I think it's a difference too, because even if there is Python interfaces, the code and design of the different tools are really coming from the Java world. And even, for example, Beam is still tied to Python 2.7. I think it's normal when you have tens of thousands of employees that you're not moving fast towards the most modern versions of Python. But probably if I'm just building a company tomorrow, I want to take advantage of the most modern thing I can. So that's also a difference. And of course, Beam at some point will go in Python 3, just because Python 2 will expire at some point. But yeah, the look and feel of the code is quite different too here. And of course, if you have data sets of the big data scales, you need to leverage cluster of workers, and yeah, the Hadoop ecosystem has better solutions, way better solutions than Bonobo for you.
And it's worth calling out the fact that, as you said, Bonobo is Python 3 only, and if I'm not mistaken, Python 3.5 and forward only. So I'm wondering what it is in the 3.5 release that you are taking advantage of that wouldn't be available in prior releases.
Okay, I don't remember when is the end of life of Python 3.4, but I think it's not so far away. There is 2 points that made me choose Python 3.5. First, it's the release that's available on Debian. Debian is known as kind of conservative distributions, Linux distribution, and so I thought if Debian think the Python 3 stable version is 3.5, I can safely assume that most of the people will do the same. That's one reason. The second reason is that 3.5 is the first one that have async await keywords built in. Before of that, you needed to use async IO. Even if Bonobo today is not leveraging async IO at all, I think in the future for some kind of nodes, not everything, but for some kind of nodes, it would be really great to leverage an event loop to have asynchronous nodes within a graph. So that's not existing from today, but it's basically the reason why I said 3.5 and the following.
And digging into how Bonobo works, I'm wondering if you can describe what the internal architecture looks like and how that's evolved since you first began working on it, and maybe what are some of the lessons that you brought into it from your previous attempts at ETL tools.
So how Bonobo is implemented today, mostly the goal of Bonobo is to help you creating graphs or directed acyclic graphs of regular Python callables. And once you build graphs, it provides tool to execute them in parallel without having to worry about all the problems that parallel programming can bring. The current execution implementation is quite simple, at least to explain. Each of your nodes, so the graphs, the callables you added into graph instances are executed in a separate thread. All those threads have input and output queues, and everything that comes to the input queue is used as argument to call your callable, and everything you would return or yield from this callable is put on the output queue. And then the graph is used to understand what output you need to connect to what inputs, and Bonobo just pass the bits of data from one node to another. There are a few advantages of doing that. First, you don't have to worry about any blocking calls that would happen in one node. For example, if you're relying on HTTP services or slow network services or on databases that would yield a lot of data, you don't have to worry about the impact of this call blocking all the other nodes, because all the other nodes will still execute in their own thread. Second, you don't have to worry about parallelism. Parallelism is quite complicated and can bring some deadlock problems and things like this. And as the only communication mechanism is queues that are managed by Bonobo, and that's simple thread-safe queues from the Python standard library, you really don't have to worry about that. And I think that's a good advantage for Python developers that may not be familiar with all the problems induced by threading and parallelism. And also, even if you're familiar with that, maybe you don't have to, you don't want to just take all your time to worry about that and use your time more to create value. Third, you're writing Python callables, so it's just very standard data structure. Not really data structure, but it's very standard programming. It means you don't have to learn some fancy stuff and complicated stuff. It's just you're defining something, returning thing, and you're just handling your data one bit at a time. Finally, and that's a property I really like with data processing, is that it's very resilient to errors in the input data, because you can, if a row fails when transforming at some step, you can easily skip just the row and continue processing. In some systems, you would prefer to stop whenever an error happened. But when it comes to integrating data, often you have 1 million rows. If 10 rows fail somewhere, you just don't want to stop all the system because those 10 rows fails. You just want to skip them for now. Have the developers fix the code and fix the edge cases that happen, and just on the next deploy you would be able to handle the 10 faulty rows, but the 1 million but 10 rows were working, so you don't want to stop everything just because of 10 rows here. So yeah, basically that's the current implementation and why I think it's a good way to do the things. And you asked about the architectural changes that happened in Bonobo, right? So I think the biggest change happened before Bonobo was born. It's the architecture change that happened between RDC.ETL and Bonobo. The biggest defect that I had by then is that the framework would add side effects to every node you would put in a graph. So it was usable if you knew about it, but for example, you could not reuse one callable from one graph to another because it would add some dirty stuff here. Basically, it would taint everything you would pass by the framework with states. It was really hard to explain to people why that was like this, because it really did not feel right to do it like this. So that's That's not really within Bonobo, but that's probably the technical explanation of why Bonobo and why rewrite from scratch with architectural changes. The second huge problem I had quite recently was that, in fact, well, there was two things, and it happened just after PyCon DE. I realized that by talking with users, I introduced too much magic in Bonobo. People were not understanding why we needed a CLI, a command line interface, why Bonobo was detecting the graph instances in files, and it didn't feel really Pythonic. And at some point, even someone told me, let's not try to turn Python into JavaScript. And I have a very good opinion about JavaScript, don't get me wrong, but he was obviously right. I was trying to reinvent wheels at some point that was not really understandable by people. So I worked a lot to suppress all this magic, and the release that just happened removed all that. Now you're just running regular Python scripts. You're using the main blocks within Python script. So you don't need the CLI anymore. You can just use the Python interpreter and run Bonobo jobs like you would run anything else in Python. And the second problem was really a tough one. As you probably know, the dictionaries in Python 3.6 are now ordered, meaning that they preserve the insertion order of items within it. And it has nice side effects, like it preserves the order of keyword arguments in a call. It's documented in Python documentation as only a side effect of the new dict implementation, which is a packed dict. I don't really know the details about that, but I felt it was a nice side effect. And it was really tempting to start relying on this 3.6 feature, which is documented as not really a feature, but maybe a bit of feature still. And I started to leverage this property for a lot of things in the development of the 0.6. Then I had a lot of problems, like the field order would shuffle when using Python 3.5. The CSV column order would change when you converted one file to another, etc. And I had to think a lot about this. Probably maybe for 2 or 3 weeks, I didn't code anything because I did not have any solution for this problem. So yeah, I thought a lot about it. And one option, honestly, was to drop Python 3.5, but I was not really happy with that, mostly because the reason I told you before was still true, and I had users use Python 3.5, so probably they would be upset. Even if I dropped Python 3.5, there was some underlying implementation, like the data structure used to pass data from within the queues from one node to another. There was starting to be complexity in this thing. The code was like hundreds of lines of code, and that was not really feeling right or feeling correct. So finally, the solution was to remove anything relying on dicts to pass data. Instead, I used an approach based on name tuples or kind of name tuples. And now every input is somehow some kind of tuple, and it allowed to remove all the complex code about raw data structures. I probably deleted like 500 lines of code here. And yeah, removing complex code is always feel right. And it also completely solved the problem of ordering fields, whether they have names, like CSV columns have names, but for example, if you have list of lists, you just have indexes, which are integers. So you could order integer indexed values or name indexed values. And also those field names are using the memory much more efficiently, because you just use it once per queue and not having it duplicated from every packet. So overall, when I started to do this U-turn, everything started to be feeling more correct. So now I was pretty confident to release this code. And although there was some BC break here, I worked with users on the upgrade process using an alpha version. And until today, everything pretty much went great for everybody. And just an anecdote here, the real fun thing is that when I started to read the Python implementation in the standard library of named tuples, I started to say, wow, that's ugly, because to describe it, it's relying on generating code. So it generates the Python code as a string, then it execute it using exec, and then it use that as the type of your data. So when you just read this, you say, why is it implemented like this? But it's really funny, because when you really dive in each detail of the implementation, it still looks ugly, but you understand why that was the only possible way they had to do that. And in fact, it's really smart because it's really efficient on the memory side. So I'm pretty happy that we went on this change now.
And one of the things coming from that also differentiates from things like Luigi and Airflow is the fact that all of the nodes in your graph of processing is just a standard Python callable, whether that's a function or a class, whereas with the Luigi and Airflow frameworks, you really need to sort of conform your application to fit their implementation target. So with Luigi, there are certain classes that you need to subclass in order to be able to create different nodes in the graph, as opposed to just being able to do free-form Python development, which is where I think Bonobo really has an advantage because it allows you to work in the same way that you have been working, but still take advantage of the underlying infrastructure that Bonobo provides to link the different nodes together and create that flow of data from one to the next.
Yes, definitely. And probably Luigi and Airflow has this need to have one level more of abstraction, which is it's great because it's very flexible and you can use a lot more systems with it, but also comes with a cost of having to adapt your code for this level of abstraction.
And you've spoken a bit about some of the different challenges that you've been faced as you've been working on evolving and growing the Bonobo library, but are there any other aspects of that process that you like to call out as being particularly challenging, whether it's related to the software itself or just the marketing or interactions with the community?
Yeah, it's nice that you mentioned that because I think the most challenging aspects of building and maintaining Bonobo is mostly everything that is non-technical. I mean, the technical part we discussed a bit just before is not really simple. Everything needs to be backward compatible. Parallelism must be transparent. You must think about developer experience, the API, how it looks, etc. But all that is challenging. But as our jobs is software engineers, that's pretty much what we do for a daily. So that's our job to solve those kind of problems, and we know how to solve those kind of problems. The really hard part is just to cut Peter Thiel. It's going from 0 to 1, from you have nothing to there is something that exists. As you said, it involves building a community around the software, both of users but also of contributors. It involves finding ways to maintain and enhance the software without like burning myself out. It involves documenting the library, making it accessible to the user base. It involves also designing the developer experience or the APIs, not because of the implementation, but because how you would like the community to use it. Yeah, as you said, it's kind of marketing the open source software. Marketing for engineers is pretty tough. It's not our strongest skill, and so it's even harder. And that's funny because in the Hacker News release, someone told me, but there is the word marketing written in some commit message, and isn't marketing evil? And I strongly disagree with that because for me, marketing is all the things you do to raise the awareness of a given target market about a given solution or a given product. And documentation is marketing. Talking in conferences is marketing. Writing examples is marketing, etc. Talking on a podcast is marketing. It's not a bad thing if you're using it to promote something that you think is good. Of course, if you're using marketing to promote selling atomic bombs, probably it can be considered as evil. But I think it's a necessary task that is not the most pleasant task for technical people, but a very necessary task to do for pretty much anything if you want it to be bigger than just something confidential you're just using for yourself. Basically, I'm trying to, it's a bit like a startup company. You're starting with some flaky product, trying to bring it into a viable state at some point where it cannot die anymore. And that's really the point here. All this marketing I'm trying to do and all this explanation about what I'm doing, I'm trying to do is trying to get the project to the point where it's not relying on me only anymore, and it can live by itself. As in a startup company, the most difficult task you have is that on day one, you're fighting really hard against the fact that, in fact, nobody gives a damn about what you're doing, and you have somehow to convince them that it can solve problem for them, it can help them doing the job, and so they should care about what you're doing. And that's definitely the biggest challenge of probably building and maintaining any open source software. Of course, if you're Google and you're just releasing something, everybody will care because you're already Google. But if you're just some developer trying to release an open source software, it's very important to try to find a way to make it sustainable, not in the terms of, I should make money with this thing, etc., but just to the point where the software is not really, I mean, if I can't at some point have it in a viable state, then probably it will die. And my task is more than developing the system, is try to find a way for it to be viable, even if maybe for sometimes I'm not here anymore, or just trying to take vacation or anything. I'm a bit confused in this explanation, but that's, in fact, a few years ago, I read a book that said something like you need to spend at least half the time you work on something actually explaining why and how you work on that thing. And probably that's the best advice I ever got, because you can make the best product in the world. If nobody knows about it, then nobody cares. It's not important. And so I think that it's actually very much more valuable to do less things and explain it better than the opposite.
And that also goes back to one of the ideas in the Zen of Python, that if you can't explain an idea, then it's probably not a very good idea. And I'm paraphrasing there, but but by being able to actually talk about the project that you're doing and explain to people what it is and why it's useful can help provide a concrete understanding for yourself about what it is that you're trying to do, and potentially even suggest some ways that you might improve it or new directions that you might take it, because by virtue of teaching people about it, you gain a deeper understanding of what it is yourself.
Yeah, definitely.
One of the things that you briefly alluded to earlier is the fact that Bonobo has some built-in extensions and converters for being able to simplify some of the tasks in ETL pipelines, such as converting from CSV to JSON as an example. And I'm wondering if you could just briefly outline some of the different extensions that are already built in, and talk about what are some of the extensions that you would like to have but don't have the time or inclination or understanding to implement.
So for now, there is different kind of extensions, but there are extensions that lives in the main Bonobo repository, and there are extensions that lives outside of that. For now, in the main Bonobo repository, you have some basic tools to work with standard data formats like CSV, like JSON, different kind of JSON. There will be soon things to read Excel files, to read XML files, things like this. I only include in the main framework what is really like 90% of people already dealt with this kind of file formats, because there is probably an infinity of file formats, and you can find in the Python C# pretty much anything you need to read, pretty much any kind of file format. So if it's not here, it's pretty much easy to implement, and you have examples on how to implement it correctly. So it will be straightforward work. And of course, I tend to encourage people to contribute, the readers and the writers, the word for the formats they use, because of course I can't do everything. Apart from the core nodes and core readers and writers that are provided with the framework, there is also two plugins, which is the console plugin and the Jupyter plugins, that provides display for interactive terminals and for the Jupyter notebooks that you probably most of your audience already know. The idea is that Bonobo should provide the tools to really understand what's happening while you execute things. Step by step, we're trying, especially with the Jupyter notebook extension, to provide additional tools to work interactively with your graphs. So it's basically tooling around the ETL and graphs of Bonobo. There is also, since the 0.6, some drafts of integration for Google APIs. So you can, for example, work with spreadsheets, you can work with Google Contacts, etc. So working with OAuth systems. I have a few extensions to work with the open data services also. And yeah, as you said, there is the SQL Alchemy extension, which is an external extension, but can help you work with databases. Now, I know what I forgot just before is that the 0.6 also released the first Django integration. So you can also very easily integrate Bonobo ETL jobs within a Django management command and just manage data within your Django manage.py file, like you would do in Django, but using Bonobo ETL. And you have some bits of integration between them. So it makes it really easy to use the Django ORM also. If you're out of the Django world, you would probably use SQL Alchemy for the SQL access. But if you're in the Django world and using the Django ORM, you can now use it also with Bonobo quite easily. So yeah, we talked before about Airflow and Luigi, so I won't expand more on that. One core thing that I'd love to have is implementing new execution strategies. I'd probably work on sub-process based strategy in the next few months because it's important to have. I need to have more than one strategy, one real-world strategy for execution to be sure that I didn't forget anything in the interface of that. But for example, and I won't probably have any time to do that in the next month, but I would love leveraging Dask and Dask distributed to allow one that would use Bonobo for a small scale thing, but that could become big, to know that at some point you can switch the strategy and with a very few adjustments, leverage a cluster of worker machine to do the exact same job. So I don't know if you've seen Dask and Dask distributed, but it's really doing a great job of doing that. So I'd really like to have Bonobo leverage this. If you want to go further than just one machine and have a cluster of 100 machines, that would really be the way to go. And also, but that's probably a whole project in itself. I'd love at some point to have a graphical user interface on top of Bonobo, probably something built with Electron and a lot of JavaScript, but that would make Bonobo a lot more accessible for less technical users, and yet still leverage the software engineering practice that I'm trying to inject in this ETL development and data engineering development. So yeah, that's probably more, and it's really open. We have a Slack channel where we discuss quite a bunch of things, but that's probably the two big things I'd really love to have in the, next year of Bonobo. That would be huge jumps forward.
Yeah, the work that Matthew Rocklin has been doing with Dask is definitely very impressive, and I actually interviewed him for an episode of my other podcast, the Data Engineering Podcast, which I'll put a link to in the show notes.
Okay.
That also answers one of the questions that I had about what would be involved in allowing Bonobo to span across multiple machines in the same sort of way that things like Luigi and Airflow do. So that's definitely an interesting direction that I think would be cool to see Bonobo taken in. And one of the other things that I believe is already built in as well is the capability of being able to generate a graph visualization of the way that the task graph is tied together so that you can visually see what are all the different steps in a given ETL pipeline that you've built with Bonobo.
Yes, but Bonobo leverages GraphViz to generate simple graph image for that. It's pretty basic, but you can visualize what you built, so you can understand graphically what the inputs and outputs look like in your graph.
Yeah, anytime you get beyond a 3 or 4 node graph, I think that would be very useful, particularly for somebody coming in to see what you're doing in your code, not having to necessarily delve through all the different lines, just to see at a high level, okay, these are the different inputs and outputs, and this is the end result.
Yes, and this is now used as a default visualization also in the Jupyter integration, meaning that if you create a graph instance in Jupyter Notebook and you have GraphViz installed, when you just just type graph, you will see the actual GraphViz image of your graph. So it's pretty easy when you're using Jupyter Notebook to work on graphs and really understand real time what you're doing, because you can just visualize it really easy.
And what are some of the most interesting or creative uses of Bonobo that you've seen?
So on my side, in our job here, we are doing a lot of Selenium-based web scraping on JavaScript-intensive websites, like things built with AngularJS or React.js, which cannot really be scrapped with things like Scrappy or just requests. So we're basically having a browser that's a Firefox browser run with Selenium that yields things from different pages, and then we have all this graph that takes this data and interpret it with for different usage. I've seen some people use it for financial stuff and some cryptocurrencies related stuff to just get things from APIs and make things in the system. I've seen some replacement of some solutions that were previously based on IFTTT or Zapier, which is a really small scale solution like trigger. There is triggers and actions, and it's pretty easy to replace some cloud-based solutions like this with Bonobo. But yeah, the creativity award, the most creative use award, definitely goes to some people that told me they are stress testing an FPGA based database system. So FPGA are like programmable processors. Honestly, I don't even know how Bonobo can be of any use in there, but it's they just told me they used it for that and they sounded quite happy about it. So probably that's I can't say how you could use it for that because I don't understand what they're doing, but that's probably just the most creative thing I heard about it.
Yeah, that's very cool. I think that they could potentially be using it for being able to orchestrate large batches of reads and writes as a way to try and determine what some of the shortcomings are as far as handling the I/O of multiple different tasks running concurrently. So that is definitely very interesting and cool. And you've talked a bit about some of the plans that you have in the near future for Bonobo, but I'm wondering if you can just talk a bit more about what you envision Bonobo becoming in the future and some of the different features that you have in mind for future versions.
Yeah, so for the quite near future, like the next two versions, which will be 0.7 and 0.8, probably the lessons learned from last release is that I'd really need to calm down a bit and try to simplify things. So I expect the 0.7 version to be not really an exciting version and mostly trying to simplify everything, test more everything, stabilize, try to get the foundation more solid. That's not the most exciting thing, but it's really necessary here. But once this will be done, I have plans for the 0.8, which is, as we are using functions in the graph, it's pretty easy to decorate functions. I want to provide tools within Bonobo to enhance node behaviors. I will give some examples for that because it's quite abstract. But for example, and it's a lot of users told me that that's pretty much what they expect from an ETL framework. For example, one behavior we could add to pretty much any node would be adding cache. So you have some key matching algorithm that says, okay, if this key is already there, then I do nothing. If the key doesn't exist, I will do the transformation and keep, for example, the result for 24 hours. You can think about rate limiting nodes. So if you're trying to use an API that only allows one call per minute, you could just say, okay, this node can only run once per minute, and whatever it has on the input queue, just run it once every minute. You can implement retry strategies on nodes. So for example, you can say, okay, this thing can fail. Try it like 10 times with 60 seconds delay between calls. If after 10 calls it didn't do anything else, an exception, just give up. But yeah, try 10 times. There is also something I briefly introduced before by talking about the async IO thing, but we could introduce non-FIFO, non-first in, first out parallel execution for some nodes. For example, if you have an HTTP API for which you don't really care about the first in, first out property, you can say, okay, this one you will make 4 calls at a time. And if, for example, if it's some geocoding, let's say API that just takes an address and gives you coordinates, you don't really care of the feeds order, you could just hammer this 4 at a time, and basically, if it's the bottleneck, speed up your transformation by a factor 4. I'm thinking also about tools to introduce step debugging, probably based on the Jupyter integration, where you could have interactive widgets allow the user to manually send one word of data at a time to help him develop and enhance his nodes. And something which is not really decorator pattern based, but that I really like to have, is to introduce some kind of recursive pattern. We talked talked about directed acyclic graphs before, but probably in some cases it's safe to introduce cycles in the ETL. And for example, when you're writing web crawlers, it's useful if you have an exit condition to have some kind of recursive crawler, because every time you read a page, you find links, so you want to read all the links and follow up to a certain point those links. So combined with the retry and rate limit behaviors, that would allow to write crawlers in really a few lines with really powerful behavior. So that's all small features, but that would add a lot of value for a lot of use cases. Yeah, for the short term, I think that's basically the plans. For the more long term, I'm also looking forward to businesses built around Bonobo and Python ETL in general. I cannot say very much about it yet, but of course the framework is and will stay 100% open source, but there's probably a lot of value-added services I could imagine around that. So I'm thinking a lot about this, and that would be also a way to get towards sustainability of the project and maybe finance the development of the project. And overall, I'd really like to see Bonobo become some kind of Swiss Army knife for everyday data. It should probably feel the natural way to go. And if you are with a terminal, then I'd like Bonobo to come to your mind when you manipulate data. And something that I didn't mention before, but which is really important, is there is a lot of use case now. You can use Bonobo without even writing one line of Python. So it's not a tool that is reserved to people that know how to write Python. There is a convert command in Bonobo that can take any file format Bonobo understands and convert it into any other file format Bonobo understands. In my job here, there is a Ruby programmer that just use it to convert files, and it don't write Python, but it as he can use the terminal, he is still able to get some value from Bonobo. So yeah, I'd really like it to become some tools like this in the future.
Are there any other topics that we didn't talk about yet that you think we should discuss before we close out the show?
Yeah, there is definitely one topic which is not really a discussion, but I'd really like to thank the 20 contributors that are in the commit logs of the last release. I mean, Bonobo is 1 year old around today, and 1 year ago there was one contributor, and today there is 20. So probably there would not be Bonobo if they were not here. So I really need to thank them before we close this.
And for anybody who wants to follow the work that you're doing and keep up to date with Bonobo and any other projects that you work on, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And my pick today is going to be an episode of the Data Skeptic podcast that discusses some of the different finer points of quantum computing. And the guest that he has on for that episode is very knowledgeable in the space and does a great job explaining a lot of the underlying principles of quantum computing and dispelling some of the hype around it, talking about the time horizons that we can start to expect some of the different capabilities that are talked about. So it's really interesting and informative episode. I learned a lot more about quantum computing than I knew beforehand, so I definitely recommend people go take a look at that if that's something you're interested in. And with that, I'll pass it to you, Romain. Do you have any picks for us this week?
Yeah, well, first I'll definitely check the episode about quantum computing you just said, because that's really a topic. My picks today, one a bit egoist, which is Medikit, but I just wanted to introduce it because it's a project I also initiated, but it's how we manage all the different projects, either closed source or open source, the same way. It's what generate the make files, it's what generate the setup.py, it's what make the releases on PyPI. So if you have release engineering to do, just check it out. I want to talk a bit about Worker, which is a project by Grammarly company, and it's a Go software. It's a software written in Go, which helps you build Docker images, but it's way better than just Dockerfile. It's looks similar than Dockerfile, but adds some commands. So for example, you can generate artifacts and exports or imports them. You can generate more than one image. You can have variables. You can have mounts. So you can, for example, have the pip cache mounted on the host. So if you're using Docker images and you're just hungry at what Dockerfiles provide, just check Worker because it's amazing.
Those are definitely projects that I'll be taking a closer look at myself. So with that, I'd like to thank you very much for taking the time today to join me and discuss the work that you've been doing with Bonobo. It's a very interesting library and one that I've actually started using myself for some of my work. So thank you for that, and I hope you enjoy the rest of your day.
Yeah, thank you very much, and thank you for having me. It was really, really great.